Hi guys, this is Mrs. Rhodes, and this is lesson number 2 in the third week of pre-cal. And our objective is the same as it was yesterday. Students will be able to identify the type of discontinuity of a function and evaluate functional limits. We're just going to practice more, but we're going to graph this time on our own. So it says sketch a graph of the following piecewise function and identify the listed properties. So the first is a line, so I know that it's straight, and it's 2x plus 12 for all the x's that are less than 4. So let me just go ahead and make a table here. So I'm going to do y equals 2x plus 12, and I'm going to do start at -4, and it's going to be an open dot because it's not equal to, and then I'm going to do -5, and that's all I'm going to need. 2 times -4 is -8. -8 plus 12 is actually a +4, so this is going to be a +4. 2 times -2, I'm sorry, is -10, plus 12 is 2. So it looks like I have 1, 2, 3, 4, 1, 2, 3, 4. It's an open dot. This one is here, and this graph looks like this. So that's that part. All right, so now let's go ahead and look at the next one. All right, it says f of x equals -1 if x is -4. So that's just the ordered pair -4, -1. So at -4, the y value is -1. And that's good. This still passes the vertical line test. And the last one is an absolute value function. And if you remember absolute value functions, I'll change colors here. Absolute value functions that, and this is starting at -4, and once again, it's open, and then I'm going above that to -3. The absolute value function means distance from 0. So the distance from 0 of -4, the absolute value of -4 is actually 4. It's just saying what is the distance between 0 and -4? And the distance between 0 and -4 is 4. So this is going to be another open dot right here. I'm just doing it in light blue. And then when -3 goes in here, the absolute value of -3 is actually a +3. The distance between 0 and -3 is +3. And then it would be, it's going to go like this. And this is what the absolute value graph looks like. So it looks like it'd be like this. That's what that graph looks like. And so that's my graph. So let's go ahead and evaluate the limits at this point. So the first thing says, as x approaches -4 from the right, this positive sign means the right. Let me change colors. That's from the right side. So when I'm looking at -4, which the x value of -4 is here, as I'm coming to the x value of -4, I'm going to be traveling on this light blue graph. So as I go up this light blue graph, and my x values, here are the x values -3. As I'm going towards the x value of -4, where is the y value headed? Like, it's not touching it, but where is it, what direction and what y value is it going to as x approaches -4? And it's going to the y value of 4. And then I'm going to go as x approaches -4 from the left. Okay, that's the negative side. So as I go up here, as I'm going up this graph, and the x value, here the x value is -5, then I'm going to keep going. As I get towards the x value of -4, once again, the y value is at +4. Now these two are the same. When the y value is the same as you approach a domain value from the left and the right, it doesn't matter if it's a solid dot or open dot. The statement as x approaches -4, f of x approaches, it's approaching 4. And the only reason it's approaching 4 here is because these two are the same. When you're the same value from the left and the right, then the limit as x approaches -4 is 4 here, because 4 was the answer for the other two sides. Now, what really is the value at x equals -4? At x equals -4, we have a blue dot here at -1. So that's really and that means the ordered pair -4, -1 is on the graph, but the limit as I'm approaching -4 is 4. So as you're approaching -4 from either side, the y value is 4. This is called a removable discontinuity, or we call it point discontinuity. All right, let's look at the next one. I'm just going to graph this one, and I'm going to let you guys, let me erase this little next value. I'm going to let you guys finish the rest. So when we look at this graph, this is the first problem. I just wanted to go over this parabola with you because I do want you to know transformations. And we went over transformations quite a bit. This is basically taking x and then moving it 3 to the negative side, or -3. This is the opposite side, horizontal shift 3 to the left. So my vertex is going to go to 3 to the left and then down 2. So this would be the vertex of this function. This is asking me to graph from x less than -3. Since that's the vertex, I'm going to go over 1, up 1, or over 2, up 1, 2, 3, 4. So this is that graph, and it's an open dot. So I shouldn't have made that little solid dot. I should make this open here, and then it's going to go like this. This is that half of the parabola. Now let's say you're not good at graphing transformations. I did want to go over that with you because it's good for you guys to review transformations. It's really important. So if we have y equals x plus 3 quantity squared minus 2, then if you were to make a table starting at -3, and then you're going to do -4, and you're going to have an open dot at -3. When you plug in -3, -3 plus 3 is 0, squared minus 2 is -2. -4 plus 3 is a -1. -1 squared is a +1. Minus 2 is a -1. So that's how I got these ordered pairs, and I would just could plug in the next point, but I knew it was a parabola, and that was the vertex. Okay, let's do the next part. This says x plus 5 for x is greater than -3. So I'm going to make another table. Whoops, I'm trying to erase this. I'm going to make another table. So this is x's, and this is y is equal to x plus 5. And so I'm going to plug in -3, and this is a closed dot because it's equal to. So -3 plus 5 is a +2. And then -2, because these are values greater than -3. -2 plus 3 is going to be, -2 plus 5 is going to be 3. So I've got at -3, 1, 2, 3, my value is 2. At -2, my value is 3. And it looks like this is probably going to go up like this then, because this is a line, and I know that. And this is a solid dot because it's equal to that. That's my graph. All right, let's go ahead and I'm actually going to leave this now for you guys to finish the rest of this on your own. With yesterday's lesson and today's lesson, you should be able to do this. And then you're going to finish this for homework.